3351 Digital Principles in Computer Organization. The topic is flip-flop, presented by Anuja AP CSE Rohini College of Engineering and Technology. A flip-flop is digital electronics in a circuit with two stable states that can be used to store binary data. The stored data can be changed by applying varying inputs. Flip-flops and latches are fundamental building blocks of digital electronic system used in computers, communications, and many other types of system. Both are used as data storage elements. So first one is SR flip-flop. This is the logic symbol for SR flip-flop. This is the circuit for logic SR flip-flop. Here set and reset. S and R. The input will be given to the NAND gate. Output is Q and Q bar. The SR flip-flop, the S and R input of the SR flip-flop are called synchronous input because data on these input are transferred to the flip-flop's output only on the triggering edge of the clock pulse. On the positive edge of the clock pulse, the circuit responds to S and R inputs. When both S and R are low, the output does not change from its prior state. When S is low and R is high, the Q output goes low on the triggering edge of the clock pulse and the flip-flop is reset. Then when S is high and R is low, the Q output goes high on the triggering edge of the clock pulse and the flip-flop is set. And invalid condition exists with both S and R are high. So this is the truth table for SR flip-flop. These are the clock pulses SR, QN and QN plus 1 and the state of the SR flip-flop. So this is the clock pulse for SR flip-flop. Then JK flip-flop. JK means Jack Gilbert, Texas Instrument engineer who invented an integrated circuit in 1958. JK flip-flop has two inputs, that is J is set and K is reset. A JK flip-flop can be obtained from the clocked SR flip-flop by augmenting two AND gates. So this is the logic gates and diagrammatic representation of JK flip-flop. Here J is equal to K is equal to 0. When J is equal to K is equal to 0, both AND gates are disabled. So therefore clock pulse have no effect. Hence the flip-flop out is same as the previous output. Then J is equal to 0, K is equal to 1. When J is equal to 0 and K is equal to 1 and gate 1 is disabled, so S is equal to 0 and R is equal to 1. This condition will reset the flip-flop to 0. The next one is J is equal to 1 and K is equal to 0. The AND gate 2 is disabled, that is S is equal to 1 and R is equal to 0. Therefore, the flip-flop will set on the application of a clock pulses. Then J is equal to K is equal to 1 means it is possible to set or reset the flip-flop if Q is high and gate 2 passes on a reset pulse to the next clock. When Q is low and gate 1 passes on the set pulse to the next clock, either way Q changes to the complement of the last state, that is toggle. Toggle means to switch to the opposite state. So this is the truth table for JK flip-flop and the clock pulses using in a JK flip-flop. So this is the characteristic table and characteristics equation of JK flip-flop. Then D flip-flop. D flip-flop, the basic SR flip-flop is used with complemented inputs. The D flip-flop is similar to D latch except clock pulse is used instead of enabled input. To eliminate the undesirable condition of the intermediate state in the RS flip-flop is to ensure that input S and R are never equal to 1 at the same time. This is done by D flip-flop. The D means delay flip-flop has one input called delay input and clock pulses also clock pulse input. Then characteristics table for characteristics equation of D flip-flop. The characteristics table for D flip-flop shows that the next state of the flip-flop is independent of the present state since Qn plus 1 is equal to D. This means that an input pulse will transfer to the value of input D to the output of the flip-flop independent of the value of the output before the pulse was applied. So this is the equation of D flip-flop. Then toggle. The flip-flop is a toggle flip-flop. It is also modified of the JK flip-flop. It is obtained from JK flip-flop by the connection with both input, that is J and K, together. It is also a single input. Regardless of the present state, the flip-flop complements its output when the clock pulse occurs while the input T is equal to 1. This is the equation for D flip-flop. The equation is Qn plus 1 is equal to TQn dash plus T dash Qn. Then master slave JK flip-flop. The master slave JK flip-flop is constructed using two separate JK flip-flop. The first flip-flop is called the master. It is driven by the positive edge of the clock pulse. The second flip-flop is called the slave. It is driven by the negative edge of the clock pulse. When the clock pulse has a positive edge, the master acts according to the JK input, but the slave does not respond since it requires a negative edge at the clock input. So this is a diagrammatic representation of master slave JK flip-flop. Application of excitation table. It is useful for analyze and for defining the operation of the flip-flop. It specifies the next state when the input and present state are known. The excitation or application table is useful for design process. It is used to find the flip-flop input conditions that will cause the required transition when the present state Qn and the next state Qn plus 1 are known. So this is the truth table for master slave JK flip-flop and D flip-flop. So this is a truth table for excitation table for T flip-flop. The realization of one flip-flop using other flip-flop. It is possible to convert one flip-flop to another flip-flop with some additional gates or simply doing some extra connection. The realization of one flip-flop using other flip-flop is implemented by the use of characteristic table and excitation table. Let us see a few conversion among the flip-flop, that is SR flip-flop to D flip-flop, SR flip-flop to JK flip-flop, SR flip-flop to T flip-flop, JK flip-flop to T flip-flop, JK flip-flop to D flip-flop, and D flip-flop to T flip-flop, T flip-flop to T flip-flop. So these are the various conditions while we are applying a SR flip-flop to D flip-flop. So the excitation table for a given flip-flops to determine the expressions for a given flip-flop inputs using the K-map. So this is the truth table and while you are using the K-map. So SR flip-flop truth table and implementation of K-map. Thank you.